Okay, good afternoon. So we're going to talk about OAM, Open Application Model, first, for the first hour until 4 o'clock. And then we're going to talk about Dapr, which is a distributed application runtime, which is on Haishi's t-shirt after that. And hopefully at the end of this, you'll understand the goals of why we built both of them and why they came about and how they'll be important to you. So let's start with the Open Application Model. The goal of the Open Application Model is to build cloud-native applications. We've seen that more and more people are building cloud-native applications that consist of microservices, which are smaller pieces of code. But what happens with it, everyone has to be tied to a particular platform. You know, they're tied to Kubernetes or tied to Docker Swarm or Mesosphere or one of these platforms. And so we wanted a way of saying, here's how you describe an application that can be deployed in many different environments. And we're building this very much in conjunction with you, Microsoft and Alibaba Cloud. And it's designed for us to solve how a developer, it's very much developer focused. How does the developer build an application and deploy this into different environments? And if you go to this GitHub here, you'll see the specification. But let me dive into some more details about what that means. So first, to be clear, what is an application model? And an application model describes the topology of your application. It's how do I have a set of services, microservices, and how do I put them together and deploy them into one environment? Yes? So one microservice can be built by one team and they write it in Node. Another microservice can be built by a different team and they write that in Java. But the whole application gets described with an application model and then deployed into a particular environment. And at that time, decisions are made about how it runs. That's different from a programming model, which is where you write the code, which is what developers do, yes? And that's what Dapr is. So just be clear, OAM's got nothing to do with writing code. It's all about how you describe the application. And Dapr is all about how you write the code, and there's nothing about how you deploy it. So today, we actually see that the general trend of the industry is that more and more developers are going to a serverless environment, and that's important. In serverless environment, you just want to build your application, you just want to describe your application, you want to write it with some code that's portable and deploy it into an environment. But certainly one environment that's dominating, that gets deployed to, is Kubernetes. Particularly in hosted environments that you own on-premise. And so, you know, today app developers have to understand each one of those environments and how they deploy things to, and that's not necessarily good. So the benefits of the open application model are three benefits that they focus on. One is it's all about developers who write applications and how they describe them, and how do they put them together and deploy them into infrastructure that it's hidden from them. So they simply say, here's my application, I want to describe what it looks like, and I deploy it. The second benefit is it separates out what the developers have to do and what the application operators, which I'll get to, the people who deploy and manage the application. They're very distinct, separate roles about who does what. So separation of concerns, where developers write code and application operators deploy the code and the application, and the infrastructure operators set up the environment it runs on. And then the third one is cloud and edge. OAM is designed to run on multi-cloud, Microsoft Cloud, Alibaba Cloud, and other cloud environments as well. And certainly what we're going to do inside Microsoft is make OAM a defining model that runs on edge compute as well, so that I can take my application and deploy it into many, many different environments. So this is very important. This is the main reason why we developed OAM. Developers focus on code, different people do the jobs that they need to do, and it runs anywhere. The problem today that developers have is they have to think about lots of container infrastructure. So if you run inside Kubernetes, you have to think about deploying into pods and to service endpoints and deployments and replica sets. But a developer wants to think about specific things that they build. So the first thing that the application model does is it defines these workload types that are very developer-focused. A service is a workload type that exposes endpoints that you can talk to. Another workload type is a task type, which is a piece of work that will run to completion and finish at a particular time. And a workload type is something that continuously keeps running and is always available to be run. So when a developer thinks about building an application, they can think in these terms of these basic primitive types, and they do not have to think in terms of the infrastructure down here. So this provides a level of abstraction about how they build their application. And you can introduce new workload types inside here. So we were talking earlier that, you know, Ali have introduced a workflow type inside here as well. So separating these out into these environments and focusing on the application is important for the developer. Going to the separation of concerns, the clear thing now here that the open application model provides is that developers write code and describe it, and I'll show you an example of what this looks like. The application operator then takes the code and adds operations to it all. These are called traits about how the code gets scaled out, how the code gets provided with identity, and these are specific things for the environment that it gets put into. So one environment may want the application to scale in a particular way, say it has manual scaling operations. Another environment maybe has auto-scaling operations. Or one environment has traffic management that comes through one particular traffic manager that provides the endpoint management, and you can configure them. So the application operator decides how the code is deployed. And then the infrastructure operator sets up the hard details of the environment, like the Kubernetes cluster or the underlying machines that need to deploy them on. So maybe one person does all these jobs. Maybe these two people work together closely, and then these people work together closely. But typically, you know, the separation of the concerns makes it very clear about who does what job as they deploy the application. And it means that the developer does not have to understand everything about setting up an environment or how to configure it all. And then finally, you know, this sums up the fact that when I build an open application model, it goes across multiple environments, cloud and edge, so I can deploy it to different clouds. You know, we're building it with you at the moment in terms of Alibaba Cloud, and it helps the abstraction so I don't have to learn every single type of cloud. So when you dive into a little bit more about what those roles look like, what it means then, if you put this all together, you have this picture of an infrastructure operator setting up physical environments like your Kubernetes clusters, your edge devices, or your physical on-premise hardware. And then they expose the open application model as many ways a serverless endpoint that you can deploy your applications into. The developer here writes code, and then he works with the application operator. The application operator creates the configurations of how the code was run, and they get created into an OAM application. And then that gets deployed through the application model into the different environments. So this is a picture that brings together the three distinct roles and how the open application model provides an abstraction to means that this application, the OAM application, can run anywhere. One particular environment that we implemented OAM on is Kubernetes. You can implement the open application model on any environment, of course. That means like Swarm or Mesosphere or Ali Cloud, but we did it on top of Kubernetes, and we provided this implementation called Rudder. And Rudder is an implementation of OAM on top of Kubernetes, such that you can build your applications, and then you can deploy them either under the covers. The implementation deploys it through Kubernetes commands, either through kube control or through Helm charts, so that the open application model generates the necessary artifacts to deploy through Rudder to Rudder, which then Rudder deploys it, is running inside your Kubernetes cluster, and launches Kubernetes components inside here as your application. So, as far as the developer is concerned, they're just working with OAM as an endpoint, but this particular implementation, and I'll show you an example of this one, shows how it runs in a Kubernetes environment. And you can implement, of course, OAM on multiple different types of environment, not just Kubernetes, but Kubernetes uses CRDs, custom resource definitions, to provide the concepts of how the implementation of how it runs on Kubernetes. And the infrastructure operators set up the Kubernetes environment with Rudder running inside it all. That allows the OAM application model to deploy the applications to that particular Kubernetes cluster. I'll show you an example of OAM running on a Kubernetes cluster. So let's go into look at an example. We'll look at an example of OAM to help make it real. What happens is OAM has 4 concepts inside it all: components, traits, application scopes, and application configuration. So this is what a developer does. A developer writes code, and they make components. So this might be a caching component, or a shopping cart component, or a website component inside here. And the component typically gets packaged in a component description, and then it has a component image associated with it, a container image. Traits are those things that the operator supplies, such as auto-scaling and the policies in the environment. So these apply to a component, and the application operator puts both of these traits and components together inside an application configuration. So an application configuration is an instance of how you deploy a set of these components. So I can have an application configuration that has multiple components and multiple traits assigned to it all. And then application scopes is how I can put a scope around a set of components that bring them together in some way. So for example, the most common one for application scope is that these 5 components live inside the same network. Or these 2 components have to be deployed together when they get deployed. I have to have my cache service deployed with my workflow service, for example. And I'll show you, let's go into an example of what that looks like. So a developer writes components, and they're put into a component schematic. That's the developer. The application operator creates a configuration file that takes the components and, using a scope to put a network around them all, then sets the traits on them of how they run, such as load balancing, identity. And then that all gets deployed into the infrastructure or the environment. So you have these stages here: write code, configure what the operator does with scopes and traits, and deploy into the environment of your choice. Let me show you this simple example, and then I'll show you a demo. So this is an example of a component that the developer writes. And you'll see here that here, this is everything inside the OAM space is defined underneath the OAM-Dev namespace. So this is describing a component schematic here. It has a particular name of the application of the component, and then you see this is this workload type. So this workload type here says that this is a component that can be a server word type, which means it can open a public endpoint to the world. It runs on a version of Linux, and here are some parameters I can hand into the components. So this developer said, you can hand me a parameter of this type string, which is called OAM texture, that sets some capabilities onto my code. And then his code that he writes is inside this container image here. So this is a container image. He writes his code. He builds out a container image that gets pushed into a repository and has a name associated with it. And then the environment variables that get handed into the container can pull in some parameters that gets set. So when I hand in a parameter here, which is this texture parameter here, I can use this texture parameter here to set environment variables onto the container when it runs. So this is all the developer cares about. He only cares about writing code, setting parameters, and saying what type of workload it is. That's all he does. The application operator, though, takes this component now, and they say how it runs. So they say, I'm going to take this component, and I'm going to put a network scope, I'm going to put a scope around it, which is a network, and I'm going to create an application configuration here. And this application configuration describes the deployment of a set of components, in this case, the front-end component. And then finally, this trait here that they place, that describes here that there will be a number, how many of them get run. So in this case, the example is I'm creating a component which is a front-end component. I have 3 of them that will get deployed and run. They're bound inside this particular network. And this is the deployment that I will call it, my own hello world. So this application configuration now can be deployed onto any different type of environment, whether it's Kubernetes, that's OAM-enabled, whether it's a Kubernetes OAM-enabled environment or Docker Swarm or whatever it takes. So let me show you an example, because I think it's better. And I'm going to switch to this microphone here, if this still works. Yes, that's good. Right. Okay. So here's an example, and this is inside. So first, if you go to OAM site, GitHub here, you'll see that here's the specification that describes what OAM is. This is just describes what the capabilities are that I went through, and there's an implementation here, which is a rudder implementation of that. And there's also a set of samples inside here. Is this scrolling? No. This seems to be dead. Oh, that seems to be dead, that side. All right. Okay. So here's an example. Here's one of the examples inside here. You'll see it's under rudder examples. This is an example of a component schematic. So this is what the developer does. He writes his application. In this case, he wrote an application called Hello World. It's a Python application. And it sets up some environment variables here. And onside my application here, allows me to have an endpoint. And that's described by this open port. I open up this port onto my server endpoint. I can actually set resources onto this image to say this can only use a CPU, a tenth of a CPU, and 128 megs of memory. And I can then hand these parameters inside here. And these parameters get mapped down onto environment variables. So this is what the developer writes. Now, the application operator can take this particular component here. Well, first I can take this component here, and it gets published into Docker Hub in this particular case. So this is my image, my OAM-Dev Hello World Python image. And then the application operator can take this component here called Hello World Python, and they can use it. They can use this component inside a configuration, which is how I deploy my application. So my application here is called first application. This is the deployment, and I start to use these components. And I create an instance of my component here, and I can hand in some particular differences to the parameters here, so I can change them if I want to. So here, the default here was these values here, but I can change them when they get deployed. And then in this case, the operator also provided a trait, which is I'm going to provide an ingress endpoint for this, so I can externally expose this container image to the outside world. So this now is very clear. Developer wrote this, application operator wrote this, and I can deploy them into my particular OAM environment. So let me switch to, was it this one here? No. one here. No. So here I have a Kubernetes cluster where I've deployed, if I do get pods inside here, I've deployed Rudder as an implementation onto this Kubernetes cluster. So this allows me to deploy an open application model into this environment. So I can now take this application here, this deployment. I can take this file here, this first app configuration YAML file, and I can do kube apply to this and push this into using the open application model to deploy it through Rudder onto this Kubernetes cluster. So when it applies this, what you'll do is it'll create an instance of this application. I can do get configurations. And it should say that I've deployed my application here, my first app, which is this first app here, into my Kubernetes cluster. And now when I do get pods inside here, you'll see that it's spun up a pod here called first Hello World app Python v1, which is an instance of this container image here. So it's spun up this inside here, and now it's running. So I can also see inside here, I can do get traits. You can see that I've also deployed into this environment traits that I can apply to this particular set of components that I deploy inside here. So you see I can have these different traits that I can use. And this ingress trait here is the one that I used inside this ingress trait here for this particular deployment. So I have traits. I can do get components. I have a set of components that I've deployed. This is my one I've just deployed, the Hello World one. I have other components, and those are ones that I can use. So the application operator can use components, they can use traits, and they can do an application deployment. So in this particular case, I can actually I can take this particular application here, and I can do a Kubernetes port forward on this, and I can port forward 999 to a local port like this. So I can open up the endpoint, Kubernetes endpoint, by doing a port forward. And because I mapped 999 inside here through this trait, I can actually expose this container through to my application. So if I now go and open up an endpoint inside here, you'll see that I should get, there we are, Hello Rudder. So Hello Rudder is what the application does. It prints Hello Rudder out, and it basically produces, this is a parameter that I can provide inside here. So this was this variable inside here. But I can change this now, so I can do this to the Alibaba like this. I can change this to, I can now change my application configuration. And this is the operator changes environment. And I can now go back and I can redeploy my configuration. So this is my configuration inside here. I can host this and redeploy a changed container. So what you will see is I don't have to think about how I've changed Kubernetes or deal with any of the infrastructure. I just dealt with my application. So if I do get pods now, you'll see that I have spun up a new instance of my container here. And now, if I go and look at the, do a port forward on this one instead, and you'll see that there's a different image this time. Let me just get that again. If I just do a different image on this, and I deploy it with this image instead, and I port forward this one instead here, and spin this up instead, it will have changed my configuration option on this. But I've still used the same code that the developer gave me. So once it starts, And I take the same port inside here, and I go back here, and I just refresh this. This will say, hello, Alibaba. So all I did now was I made it very distinct that I could just change a value inside a parameter here that got mapped into an environment variable inside here called target that was used inside the code. And if you actually went and looked at code, you say, in fact, I think you can go and look at the code under the examples. It just takes target and just prints this out as a message like this. So this shows a very simple example of how I've built an application, I treated it as a component, configured it together, deployed it, and now I can put it into any environment of my choice. Let me just quickly go back to slides. And so on here, the rest of these examples run through a similar thing like that. And if you want to spend more time understanding what OAM does, go and visit the GitHub inside here. We have a mailing list and a community meeting that happens inside here. This is how you can find out more. So at this point, I'm going to hand it over, and I'll let you talk about Alibaba, what you have done with Alibaba on this.